Okay, here we're going to go to part B of section of 3.6. So part B is logarithmic differentiation method. This method is used when we're dealing with y. An example: y equals sine of x raised to sine of x. So a function raised to another function. What's the derivative? Okay. So we cannot use the power rule because this is not an integer. I mean, this is not a number. The power is a function. We cannot use e to f of x because there's no e. We cannot use a to f of x because a is a number. We don't have number there. So none of the stuff we did, we may not be able to use that as it is. So we needed to figure out a way to take the derivative of y equals sine of x raised to ln of x. So that's the method that is presented to us is the logarithmic differentiation. So how does it work? Well, step one, basically when they give you a function like this to differentiate, you will have to first apply natural log to both sides of the equation. Okay. So you take natural log of y equals natural log of the other side, which is natural log of sine of x raised to ln of x. So precalculus says, remember this property of precalculus, if you have ln of a raised to b power, you can actually drop b right in front of natural log, and then be able to get b times ln of a. So this has been dropped right in front of ln function. So we're going to use it here. So we have ln of sine of x raised to ln of x. So we can drop this ln of x right in front of ln. Okay. So we can get ln of x times ln of sine of x. So we are here now. So the first step was to apply natural log to both sides of the equation. The second step now is to ddx the equation. We're going to take the derivative of this equation with respect to x variable. So remember, when you take remember this, when we did, we said if you go on the second video, when you take the derivative of ln of f of x, so the answer was 1 over f of x times f prime of x. So this time, when you're taking the derivative of y with respect to x, so it's like you're putting y for f of x. So y is going to go, is here, it's going to go here for f of x, and it's going to go there for f prime of x. So the answer is going to be basically 1 over y times y prime. So which is y prime over y. So what does it tell you? When you ddx the equation, okay, so you're going to ddx the equation. So ddx of ln of y equals ddx of ln of x times ln of sine of x. Now, we already know the answer to this part. The answer to this part will be y prime over y. That's what we said here. If you take the derivative of ln of y, it's basically y prime over y. So on the left side, we know it's going to be y prime over y. Or since we're using ddx, we can write it as 1 over y times dy dx. Okay, so that's like y prime. So y prime is dy dx. On the right side, we have two functions, so that becomes a product of two functions. When you're taking the derivative of a product of two functions, you'll have to bring the product rule of derivative. So what you're going to do is take the first function times the derivative of the second plus the second times the derivative of the first. So that's the product rule. So derivative of ln of sine of x is 1 over sine of x times sine of x prime, which will give us sine of x prime is cosine of x. So over here we're going to have ln of x times 1 over sine of x and then times cosine of x. Now on the other side, when we take the derivative of ln of x, we know it's just 1 over x. So it's going to be 1 over x times ln of sin of x, which you multiply 1 by ln of sin of x, you get ln of sin of x over x. So we also know cosine of x over sin of x is cotangent of x. So we can replace these two by cotangent of x. So we end up with ln of x times cotangent of x plus ln of sin of x over x. On the other side, the left side, we have 1 over x times dy dx. So we have this equation. So step 3 is then to solve this equation for dy dx. Okay. So basically, we need to remove 1 over y, meaning if we can just multiply this equation by y both sides, we will cancel 1 over y. So, but because we're trying to find the dy dx, so dy dx is going to be basically equals to y times the right side, the entire right side. Okay, so we're looking for dy dx. Now, we don't stop here. We continue by going and replacing y by the function. Remember that originally y is a sin of x raised to ln of x. So the entire right side should be a function of x. We cannot see y here, so that's why instead of keeping y, we'll have to replace y by sin of x raised to ln of x, and then times your open bracket, you put ln of x cotangent of x plus ln of sin of x over x, and then you close your bracket. So that is the answer for the derivative of that function sin of x raised to ln of x using the logarithmic differentiation method. Okay, so we have another example quickly. Okay, so for this example, they give us y equals x raised to cosine of x. Again, you want to find y prime, so you copy the function, you apply natural log to both sides. Okay, so you get this, and then use the property of natural log to drop cosine right in front of ln. So you get cosine of x times ln of x, and then step 2, you ddx the equation. Okay, so you apply ddx to both sides of the equation. And we know anytime you're doing logarithmic differentiation, when you apply ddx to the left side, you will always get 1 over y times dy dx. So this should not be a doubt, because you're taking the derivative of ln of y with respect to x. So you get 1 over y times dy dx. On the right side, again, you have a product. So you're going to use the product rule of derivative, meaning you're going to take the first times the derivative of the second plus the second times the derivative of the first. So derivative of ln of x is 1 over x. Derivative of cosine is negative sin x. Okay, so you end up with cosine over x minus ln of x times sin of x. From here, then we go to step 3, where we need to solve for dy dx by just multiplying both sides by y. So when you multiply both sides by y, this y cancels out, and then on the right side you have y times this whole quantity. But then we don't stop here as the answer, because we still have y. We're going to go and replace y by x raised to cosine of x. Okay, so we plug in x raised to cosine of x for y, and then we finally get the final answer. Okay, thank you very much.